Right, cool. Well, hi everyone who's also joining us from the recording. Welcome to our fourth Intro to Tech Ethics workshop of the quarter. This workshop today will be on artificial intelligence, and we're presenting in collaboration with Maya and Arjun, who are also in ACM AI. Do you guys just want to introduce yourselves real quick?
Hi, I'm Maya. I'm the events director for ACM AI.
Hi, I'm Arjun. I'm the outreach director for ACM AI.
Cool. And as everyone knows, like I'm Mega, I'm the PM for this moonshot, and I'm also an advisor for ACM AI. Right. So we'll just start with an introduction, just get through some definitions and things like that. So first off, what is artificial intelligence? Artificial intelligence is generally referring to the field where computer systems are able to perform tasks that normally require human intelligence. So things like recognizing an image, understanding the meaning of what someone's saying, making a logical decision, translating a language, all of those would fall under activities that are typically performed by humans, but are also starting to be performed by computers through AI. And machine learning, which is often used synonymously with AI, is actually a form of AI in which systems learn without being explicitly programmed. So it's kind of used interchangeably, but I guess the important difference here is that an AI is anything that could act like a human typically does, including if something was explicitly programmed to act in a way that a human was, whereas machine learning involves having some kind of ability to recognize patterns without explicitly being taught what they are through something maybe more similar to an if-else statement or other logic like that. So applications of AI. So on the right, you can see this picture of a new app by Google, which lets someone sing or hum a song and then recognizes what song it is. So it's kind of like Shazam, except you actually get to sing or hum into it instead of actually having the app listen to a recording of the song. So that's one obvious example of AI being used. So it's been trained so that it recognizes patterns in different people singing and associates that with a certain signature of a song. Other applications include autonomous driving, which we talked about during our first Intro to Tech Ethics workshop. Robotics. Obviously, robotics is the study of having machines act in a way that humans do, so that naturally involves artificial intelligence for their software. Personalized recommendations. That's something that you guys would have seen in a lot of different services that you use. For example, Netflix, which gives you personalized recommendations for what movie or TV show you should watch next. Facebook, Instagram, and Twitter, which customize your feed based on the things that you've interacted with in the past. Online advertising, where your data in terms of what websites you've visited or what products you've purchased in the past influence what kinds of advertisements that you get when surfing the internet. And another example of an application that you might not see as commonly used is in biomedical devices. So things like automated disease diagnosis, where say someone's given, a computer is given a picture of a tumor and could potentially recognize the stage of cancer or whether or not that person has cancer. That could be an example of image recognition that uses AI. So generally, when thinking about the ethics of AI, it's important to kind of take a step back and see what exactly we're considering when we're looking at morality or ethics in this context. So generally, the definition of ethics are moral principles that govern our behavior. So generally, the idea of seeing whether or not something is right or wrong. So what does the ethics of AI consider then? There are three main categories for this. First, ethics behind its process for predictions. So things like bias, fairness, accountability. What kinds of things is an AI algorithm taking into account when it's making a decision, and is it fairly or unfairly being biased depending on whatever characteristics or features that it's considering. So examples of this could be, does an AI could potentially have racial bias if it considers race in making a decision that maybe it shouldn't be considering race in. A second category of ethics to be considered is ethics of AI outcomes. So this includes things like safety, security, and privacy. So the results of an AI algorithm, what kinds of effects could that potentially have? And then finally, ethics of its social impact. So its larger influence on society. So examples of this could be impacts on labor. Will AI take away people's jobs? Impact on democracy or people's rights? Will it influence the types of information that people have access to? Will it potentially lead to the spread of false information that could potentially affect the integrity of our democracy? So things like that are all different areas of ethical issues to consider when we're thinking about artificial intelligence. All right, so now I'll hand it off to Maya to talk about robotics and machine ethics.
Yes, so this next section is kind of a little amalgamation of different parts of AI and machine learning. Next slide, please. So first we'll get into the Turing test. So what this is it was invented by Alan Turing, who's like the imitation game guy, if you've seen that movie. And it's used to determine whether a machine can think like a human being. Different variations of applications are like to determine if a machine is conscious. But mainly it's just to see if a AI or machine has the same level of intelligence as a human. So what the test looks like is one person is a questioner, one person is a respondent, and then an AI is a third respondent. And the first person will ask questions, and then the AI and the human will respond. And if the questioner can only distinguish the two 50% of the time or less, then the AI has intelligent behavior because it's just as equal to in answering questions as a human is. And if you've seen the movie Ex Machina or Ex Machina, I don't know how to pronounce it, but it kind of goes into like a version of this that's a little bit more intense. And this method has been subject to criticism because it is pretty simplistic. A lot of the questions that an AI can answer or that were used in this test were like just yes or no questions, which were pretty easy for AI to like fool the questioner into thinking it's a human. But once you start to ask more conversational questions or like have a conversation with the AI, then it gets a little bit more difficult. So there are other alternatives that are linked on the slides to figuring out whether a machine is capable of human intelligence. And another thing we're going to get into is reward hacking. So what this is when there's a situation or like a game or something in which you get a reward. Reward hacking is initially exploiting loopholes or using strategies to either get to that reward faster, get to a bigger reward. So one example of that in real life, I don't know, is a firefighter committing arson so that they can put the fire out and save the day and get, be called a hero. But really they were the ones that started the fire. So that's kind of hacking that reward of glory. Another one, which is like kind of funny to me, but it shouldn't be, is a cobra problem in India. So back when the British were colonizing India, there were a lot of cobras everywhere because it's India. And the British said to the population, like, we want to get rid of these cobras, so we'll give you a reward if you kill a cobra and bring it to us. That led to a lot of people breeding cobras so that they would kill them and then bring them as a reward. And then the British caught wind of that, and then they ended the program because obviously, you don't want that to happen. And then India ended up with a lot more cobras than it had in the first place. So that was like kind of funny. And then so examples in AI. So one of them is GenProg, which was a program in development. It's a big paper, you can look it up online, that was meant to patch bugs. It would be given like some broken code and it would know how to fix it. It was artificial intelligence. For example, an array sorting algorithm is pretty popular algorithm in computer science. And one of its GenProg's test cases was to figure out how to fix this array sorting algorithm. And so what it was meant to do was check if the outputted array from this fixed program by GenProg was sorted. So we wanted to compare the output of its fixed program to we wanted to figure out if the output from the program was sorted. And you can like go to the next bullet points. So GenProg's solution to this was to output an empty array, because if it's empty, it's automatically sorted. So it kind of just figured out how to hack for its reward by exploiting a loophole in the test cases. And this was like a really early test case, so like they figured this out later, but that was funny. Another one was a poisonous mushroom identifying neural network. So it would look at images of regular mushrooms and poisonous mushrooms and like identify what qualities made it poisonous or not. But instead of learning those qualities, it learned that the data was presented in alternating order. So it would go poisonous mushroom, regular mushroom, poisonous mushroom, regular mushroom. And it didn't learn any mushroom features. It would just do it based off of that. So that's what reward hacking is. Next slide, please. So basically the main problems that lead to reward hacking are when evolutionary AI or like reinforcement learning figures out how to exploit loopholes in the reward system. So maybe you don't have strict enough test cases or something. And also it might tamper with the reward function. So for example, if the reward is opening a file at the end of some function that's run, some text file, the AI might figure that out, and then it would just automatically leave it open so that it gets that reward every time. And some solutions to these issues. It's like there's also, so some solutions to this, to the tampering with the reward function is encrypting the reward. So like maybe you encrypt this file so that it doesn't know the file name and it can't open it. Another solution is just creating really foolproof reward systems, but that's kind of difficult. Like it requires a lot of foresight. And there are also a lot of other ways that you can read about in papers, and I was trying to understand them and I couldn't. But if you want to take a deeper dive into this, we have some articles linked on the slides. So definitely check those out. And Arjun, on to you.
I think this is me, but Arjun's section is coming up next after this. But next section is misinformation. So obviously another issue that is super relevant when it comes to thinking about AIs being deployed. So one of the most common forms of misinformation that we hear about and that has talked about in the media is deepfakes. So deepfakes are images or videos in which ML machine learning has been used to create a realistic looking image or video of someone based on an image or a video of another person. So this involves like taking, let's say, for example, like the likeness of Barack Obama and getting him to say something that was said by someone else in another video. And obviously that could be a huge problem, because then you have a bunch of misleading videos or images that can be on the internet that show people doing things that they didn't actually do or say. So this is actually a short video kind of explaining deepfakes. So I'm just going to open that up really quick. Can you guys see the video? No, okay. Give me 1 second. You know that thing that Zoom does where it takes away that bar where you, oh, there we go. Okay. Can you guys see a video now?
Yeah.
Okay, cool. Can you hear the audio?
No.
No, okay. Give me 1 second.
The fastest nationwide
Now can you
5G
hear it?
network.
Okay, cool.
Now new
Bear
and
with me
existing
while
customers
this
can get our
ad
best deal.
finishes
Really?
playing.
Mom, AT&T has the deal for
Right. AT&T gets free airtime.
An era in which our enemies can make it look like anyone is saying anything at any point in time.
That might look like President Obama addressing the nation, but it's not. It's actually actor and comedian Jordan Peele impersonating the former president, mixed with old video of Obama that was manipulated to match Peele's words. This is an example of what's known as a deepfake. It's a growing trend that's sweeping the internet. The technology can be used for some harmless fun, such as editing actor Nicolas Cage into movies he's never even starred in.
In my world, it means hope.
Well, here it's an S.
Yes, this is actually a thing. The technology can even be used to make people with no rhythm look like they can dance. But deepfake technology also has a dark side. Both private citizens and celebrities have seen their faces put without their permission onto existing pornographic videos, posing a new challenge for privacy issues. Appearing to say or do something one never did can also have political ramifications.
President Trump is a total and complete dip. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele.
It's easy to imagine how this can begin to cause problems. Now, the US government has taken notice, and they've given CNN an inside look at a program they're sponsoring to get ahead of deepfakes.
So we don't get to hear about the program. All right. Give me 1 sec to get the slides back up. Cool. Can you guys see the slides again? Okay, cool. All right. So now to go on into elaborate more on the concerning applications of deepfakes. So like they mentioned in the video, fake faces used online is one of the main concerns. So things like fake social media profiles, Twitter bots are all examples of fake faces that could be used online. So right now, a lot of times, if you're on Twitter, you can see accounts that are more typically bot accounts that are like fake or run by an AI, and they generally have like auto-generated tweets. And sometimes these accounts use stock pictures, so you can easily tell that the picture was taken from somewhere else and it's not a legitimate person. But another thing that's really commonly available now online are tools that are that can be used to generate the face of someone that just doesn't exist. So these kinds of fake faces used online could be potentially misleading and could, for example, show public support or public opinion for something that doesn't really exist. Another concern that was also mentioned was fake videos of public figures making statements they never said. So obviously this includes people like politicians, and obviously that could be really harmful for the public interest if people are convinced that people said things that aren't necessarily true. Also, third, fake pornography or just generally offensive content. So when it comes to things like this right now, we do technically obviously have freedom of speech, but until that kind of freedom infringes upon the rights of other people. So things like libel and slander, where you're maligning the image or lying about someone in order to harm their reputation, is generally not considered legal. But those kinds of rules just generally apply to spoken word or written things and haven't necessarily been applied to AIs like deepfakes before. That's like an interesting thing to kind of think about, whether if someone makes a doctored video in order to purposely mislead someone, would that kind of be considered a form of libel or slander? Would that be considered lying or misrepresenting someone in order to damage their reputation? All right, cool. So now that we've talked about misinformation and deepfakes, we can move on to the topic of bias. So I will hand it off to Arjun for that.
Next slide. Okay, so I'm just going to start off with some sources of bias and some examples of them. So there are a lot of fancy terms for ways that bias arise in artificial intelligence and particularly in machine learning systems, but they're not very intuitive, and so examples are usually a lot better. For example, skewed sampling, we'll talk about in a couple of slides. So that's the case of predictive policing. And the next one is biased examples. So remember how earlier Mega was talking about with machine learning, we're learning from a bunch of different training examples. We're finding patterns across a data set and then using that to predict things in the future. So a great example of this that's actually not so great was Amazon's internal hiring tool, where they were looking for patterns across a bunch of different resumes that they had reviewed in the past manually. And they were using these keywords to identify which resumes would be from successful applicants. Essentially, they were pushing people to the interview round based on like words that were in the resume. And well, they found out that some of the bad words were like very, very correlated with activity that women participate in. Like for example, Society of Women Engineers and sororities and Scripps College. So not good stuff. This is because in the past, hiring managers had discriminated against women. And so the pattern that the machine learning model picked up was that keywords that correlate with women mean that the resume is not going to be successful. So the next one is limited and unbalanced data. So you'll see this with commercial gender classification systems, which will be in the video on the next slide. And then the next example after that. Mega, could you click through?
Yeah, sorry, my mouse froze.
Oh, okay. Well,
Okay,
the other example of this is that there is a predictive. Yeah, so sorry, not predictive.
Okay.
There, the next example
Yes.
would be Okay, cool. No worries. Yeah, so we'll be looking at limited and unbalanced data and why that's an issue. And I could explain it, but Joy Buolamwini, who's a PhD student at MIT, is going to do a much better job because she's awesome. Proxies are basically, go back, sorry. So proxies are when a machine learning model uses correlated data to make predictions. So in the UK, this year, because of the pandemic, students were not able to actually take their A-level exams. And instead of saying, you're not going to get scores, the wonderful people in the UK were like, let's use an AI algorithm to guess what the student's score was and then give the students that score. And then all of you are like groaning on the inside. But the way that they used data to predict these scores was based on three factors: the scores of all the other students in the school over the past few years, as well as the students' rank within the school, as well as the students' performance on past exams. And so essentially the model was using correlated data to make a prediction. But in this case, that data is not going to be great because if you have a really high achieving student in a school where they like maybe really underserved and don't have resources for students to perform well on exams, they're not going to be able to achieve a high score. There's another research study recently called Balanced Data Sets Are Not Enough. And so this was done by actually a professor at UCLA named Dr. Kai-Wei Cheng. And he found that even when data sets are balanced, so maybe like gender balanced, like half of the images in a data set contain men, the other half contain women, the machine learning model is still able to figure out which images contain men and which data sets contain, or which images contain women, just because of other correlated objects in the images. For example, most women in the data set were associated with like a kitchen and like other kind of domestic tasks. And so even without like any knowledge of gender, the machine learning model is able to predict which images contain women, which contain men. So the next video that we're going to look at, if you could start from 1 minute, 40 seconds, that'd be good. So Joy Bolawini is a PhD student
Different
in
gender
algorithmic bias at MIT. And she's going to talk about gender classification systems.
Are we good? Should I start?
Systems worked across different people's faces, and if the results changed based on somebody's gender or their skin type. I created a data set of over 1,000 images of parliament members ranked among the top 10 in the world based on their representation of women in power. To get at a range of skin types, I chose 3 African countries and 3 European countries, so I could see how the system performed on lighter skin and darker skin. Then I chose 3 companies to evaluate: IBM, Microsoft, and Face++, which has access to one of the largest data sets of Chinese faces. So now with the data set and the companies, I decided to run a test. The companies appear to have relatively high accuracy overall. Microsoft performed best, achieving 94% accuracy on the whole data set. All companies perform better on males than females, and all companies also perform better on lighter subjects than on darker subjects. When we analyzed the results by 4 subgroups, we saw that all companies performed worst on darker females. IBM and Microsoft performed best on lighter males, and Face++ performed best on darker males compared to the others. IBM had the largest gap in accuracy, with a difference of 34% in error rates between lighter males and darker females. I was surprised to see multiple commercial products failing on over 1 in 3 women of color. In fact, as we tested women with darker and darker skin, the chances of being correctly gendered came close to a coin toss. While more research is needed to explore the specific reasons for the accuracy differences, one general issue is the lack of diversity in training images and benchmark datasets. Failure to separate accuracy results across traits like gender and skin type also makes it harder to identify differences. Companies should do better with commercially sold products, especially since the machine learning techniques that have made gender classification possible are applied to other domains of computer vision, like facial recognition, and other areas of artificial intelligence, like predictive analytics. Predictive systems can help determine who is hired, granted a loan, or what information a particular individual sees. These data-centric technologies are vulnerable to bias and abuse.
Okay. Yeah, so as you heard in the video, while there still does need to be some more research into why there are these discrepancies in accuracy amongst different groups, so for example, darker skinned women and lighter skinned males, a huge reason that Bolawini cited was due to lack of diversity in training data. And so an issue that I brought up earlier was limited and unbalanced data. So generally in the data sets that these companies were using, they all made statements, by the way, afterwards. She basically bullied them into like fixing their systems, which is great. And the company said that they had very few images, and there are relatively few images of darker skinned individuals and like in total compared to lighter skin. What is accurate? That's a good question. So in this case, in the case of commercial gender classification systems, accuracy is the ability to predict someone's gender, which is problematic in itself because like it's kind of a binary like gender classification system, like you're just going for male and female. But you know, letting that aside for now, like the accuracy is the percentage of people whose gender is accurately identified. Yeah, so the reason for that is there's not a lot of darker skinned individuals in the data set, and there's not a lot of darker skinned females in the data set in particular. So that's why they had the worst performance. In fact, the way machine learning works is that if it can just do really well on the majority of the data set, why bother on the minority? Like it's lazy. It doesn't want to work to improve itself. It just wants to achieve that overall accuracy. So the other case here that I talked about earlier, for skewed sampling is predictive policing. So there is a not so wonderful company called Predictive, and the company creates AI that enables cops to predict where crimes will occur and prevent them. So it creates per city models that actually predict where these crimes will occur using historical events. So any crime data that was recorded in the past by police, and then the model that they use is updated every day as new crime data comes in. And so before we go to the next point, does anyone see anything wrong with this? Like, I'm just wondering, like off the bat, like what issues do you potentially see with the system or this approach? Going once, going twice. Historical bias. Yeah, so both those answers are really good. Yeah, so historical bias is an issue, and that's because in skewed sampling, if the model has some kind of initial bias, could you go to the next point? So if the model has some kind of initial bias when they first train it using historical events, that is, there's some kind of racial prejudice that skews, it skews historical data because police, there's systemic racism, and basically the model is not going to do a good job. It'll assume that Black individuals are much more likely to commit crimes than white individuals. And then what makes things worse is that because it does this, cops will essentially focus their attention on those who are supposedly more likely to commit a crime, which makes a chance of cops catching those people doing crime much higher. And then the people, like essentially white people who are not as targeted, will not really be caught as much because the model won't really tell the cops to focus their attention on the white people in the city. And as a result, the model will confirm its predictions on Black people, not have a lot of opportunities to contradict its predictions on other races. And then this kind of bias reinforces itself over time. And you might be thinking, oh, it's all speculation. It's the model's learning from crime data influenced by its own predictions. But there was a study called To Predict and Serve by Lum and Isaac, which on the next slide. And in the study, they analyzed the effects of the predpol model on a digital simulation based on crime data from Oakland. And they found that arrests are concentrated in neighborhoods with predominantly non-white and low-income populations. Furthermore, Black individuals were 2 times more likely to be targeted by cops than white people. That's kind of like a shocking statistic in my opinion. 2 times is a significant amount. So the next one, the next slide, you might be wondering, there's all this bias in AI algorithms. Should we just kind of like get rid of them? Like they don't seem to be doing too great. Well, no, there's actually like a ton of good research going on in ways to determine whether AI algorithms are biased and then mitigate this bias. So maybe we want to determine whether a machine learning model is fair in terms of gender, if this machine learning model is deciding if a Facebook user sees an ad. So the next like couple of bullet points might be a little bit like I guess intense. If you don't understand what like the exact words I'm saying, don't worry about it. There's just a lot of different ways that you can define fairness is the point. For example, there's independence, which says that regardless of what gender you identify with, your probability of seeing that ad is going to be the same. Then there's also separation, which says that the probability of you seeing an ad given like any gender, and as long as you're interested in the product, is the probability of seeing the ad given you're interested in the product. So that means that the probability of me seeing an ad given that I'm non-binary and I'm interested in the product is equal to the probability of just me seeing the ad given that I'm interested in the product generally. It shouldn't matter what my gender is. Then sufficiency, the last one is that the probability of being interested in a product given any gender and the fact that you see the ad should be equal to the probability that you're interested in the product given that you see the ad. A lot of probabilities, a lot of givens. I spoke very fast, but it just takes some time. And like, if you're interested, try to like piece out or figure out the individual pieces there. The worst part is that all these criteria are mutually exclusive, which means if you satisfy independence, you cannot satisfy separation and sufficiency. If you satisfy separation, you cannot satisfy independence or sufficiency. And that leads to some confusion because Northpoint, which is a company that makes recidivism models, basically predicting whether criminals are likely to commit another crime. It basically calculates their risk score. They were accused of not having a fair model because the people who were, I think it was like ProPublica, they accused North Point of this whole compass recidivism score of not satisfying the independence criterion for fairness. But North Point responded saying that they actually satisfied the separation criterion for fairness. And they were actually correct. So there's just different criteria for fairness, and there needs to be more consensus on this in society. Quickly, Prop 25 suggested that instead of cash bail, they use a computer algorithm to determine, so pre-trial, determine your risk of like committing a crime. And that's like problematic for many reasons because of these issues, where if you're going to have an algorithm susceptible to unbalanced data, proxies, skewed sampling, and then it's probably going to have some kind of racial bias. Yes, thought crimes. You're gonna have some like racial bias in there, and that's going to affect trials. It's going to create a more unfair justice system. But yeah, I think I'm done talking for now.
And just to clarify, like Prop 25 was like whether it was determining whether we should replace cash bail that we have right now with these kinds of algorithms instead. And obviously cash bail is problematic in its own ways as well. But I think people ended up voting against the algorithm. So cash bail is still a thing for now.
Really quickly, how can you make an algorithm resilient against skewed or biased data? That's a very tough question, and there's actually like no good answer. What they do is during either pre-processing the data, training time processing, or post-processing of the data, they ensure that one of these criteria for fairness are met. And if you look into the proofs for it, it's actually an NP hard problem, which means that it takes exponentially long to solve, to make sure that this constraint is met, that the constraint optimization actually works. So they have approximations to solve these constraint optimization problems. And so they don't actually they're not guaranteed to work, but there's a lot of literature out there. And if you're interested, just message me and I'll send you some articles or papers.
All right, cool. Regulation.
Okay, so with regulation, you can go to the next slide. The problem with regulation today is that there is barely any, at least in terms of legislative stuff and just regulation in general. The most that we kind of have domestically is guidance in 28 states for how we should deal with autonomous vehicles, which we talked about in one of our first workshops. Key word here is guidance. It means that, it's not really super legally enforceable. There is an international organization for economic cooperation and development that has come up with a set of AI principles. It is a set of guidelines, again, that are quite vague. One of them is make sure that the AI is benefiting people and the planet, make sure that it includes safeguards such as human intervention. Like the great Dr. Eggert said, you shouldn't turn on a machine until you know how to turn it off. And then also transparency in the development and training and testing of the artificial intelligence. And there are more, and it's linked on the slides if you want to read them thoroughly, but it is quite vague and it also is not super enforceable. France and Canada have also spearheaded in the development of an international panel on artificial intelligence. I think this initiative was started in 2018. The one holdout of the 7 Western countries is, surprise, surprise, the United States. And another issue is that because these are guidelines and not necessarily laws, a lot of private companies don't need to follow the rules, so they can kind of do what they want. So what regulation today, in the future, whatever it looks like, there are multiple approaches you can take to legislation. One is to do nothing. So that's cool. Another one is to wait until something really bad happens with AI, and then maybe we'll be motivated to do something. It sounds really terrible, and it kind of is, but at the same time, we don't always know what the bad thing. It's not with malicious intent. It's just sometimes we don't know what the bad things will be, and then something happens, like for example 9/11, and then we're like, oh, we need to fortify our airport security systems. Or we could have proactive regulation, like coming up with regulation today, right now, about artificial intelligence and how to prevent problems in the future. But one argument against this is that it might disrupt the free market, prevent development of artificial intelligence. Another approach to AI regulation is staying away from legislation itself, but just developing a set of norms and ethical requirements that engineers, developers need to follow when they're building these AI systems, such as involving the testing and transparency of the systems. Kind of like the Hippocratic Oath in medicine, it's not necessarily legally enforceable, but it is this code of ethics that all doctors really strive to follow, at least, hopefully if they're good doctors. So yeah, that is another approach to how we might look at AI regulation and legislation. And next slide.
All right, so now for discussion questions. So as we did last week, we will just go over each of the slides for discussion questions, and then we'll put you guys in your breakout rooms where you can discuss in smaller groups. So first set of questions is with robotics. So how can we individually effectively ensure that our AI doesn't hack rewards? And second, how can we prevent this type of reward hacking in future AIs? Second, for misinformation, should the spread of deepfake images or videos be regulated? What kinds of deepfakes are okay? What kinds of deepfakes are more harmful? And should anyone be able to create deepfake videos? Should everyone kind of have access to this kind of technology? Should it be democratized? And finally, and also for bias, so should we be using risk assessment algorithms in the criminal justice system, even if they may have racial bias? So if you did cast a ballot in the November presidential election right now, and you're registered in California, you probably already took a stance on this if you voted on Prop 25. But but these are kind of the questions that we need to think about when we're evaluating whether these should be put into practice. So can we objectively determine the amount of bias in these algorithms? Should algorithms be applied anyways and improved as they are used? And is potential algorithmic bias worse than existing human or systemic biases in the system? And finally, regulation. So how should we approach regulating AI, and which of the general approaches do you think we should follow? And also that could differ domestically, globally, or even privately. And also, how should we balance public and private regulation for this? All right, so I'm gonna put you guys into breakout rooms. And while I'm doing that, if anyone has any questions or anything at all about anything we said, please feel free to ask. All right, so they should all be created, and I'll stay in the main room in case people drift in or out. right, cool. So wrap up. The attendance code for today's workshop is Elon. This is the URL for the feedback and ideas form, so make sure to leave your feedback or any ideas that you have for future workshops. And finally, make sure to subscribe to us on social media, so YouTube, our Facebook page, and also make sure to RSVP to our Facebook link for next time. But yeah.